Hello everyone, welcome to another exciting math problem. Today, we have an interesting and challenging question that involves Vieta formula. Here is the problem. Suppose alpha 1, alpha 2, all the way to alpha 6 are roots of the equation x power 6 minus x power 4 plus 1 equals 0. Our task is to find the value of the summation of alpha k to the power of 12, where k equals 1 to 6. As mentioned, it is related to Vieta formula. Now let me offer you more hints. Just consider sum of the roots, the sum of square of the root, and the sum of the reciprocal of roots. Now I encourage you to take your time, stare at it, and ponder this expression. Please do not give up easily, and if necessary, don't hesitate to get help from some technology to solve this puzzle. When you're ready, we'll explore the solution together. Let's begin. Let's introduce some notation for clarity. We'll use Sn to represent the summation of alpha k to the power of n, where k equals 1 to 6. As we are dealing with the roots of the equation x power 6 minus x power 4 plus 1 equals 0, the Vieta formula comes into play. It tells us that the sum of roots, which is s1, equals 0. And the sum of product taken 2 at a time equals -1. Now, the sum of square of the roots can be expressed as the square of the sum minus double of the sum of product taken 1 at a time. And therefore the answer equals 2. Since the alpha are roots of the equation x power 6 minus x power 4 plus 1 equals 0, then 1 over alphas are roots of 1 over x power 6 minus 1 over x power 4 plus 1 equals 0, which is equivalent to say x power 6 minus x power 2 plus 1 equals 0. The sum of the reciprocal will be equals to 0. Similarly, the sum of the square of the reciprocal equals 0. From the given equation, we can write as x power 6 equals x power 4 minus 1. By dividing each term by x power 2, we obtain a key insight. That is, x power 4 equals x power 2 minus 1 over x squared. As alpha are roots of the equation, each of the alpha k satisfies the equation. This means that the following holds. By taking the sum, we have S4 equals to S2 minus S negative 2, which is equals 2. Again, from the equation x power 6 equals x power 4 minus 1, we may get S6 equals to S4 minus 1. However, this is a common mistake made by a lot of students, because when doing the summation, S6 actually equals to S4 minus 6 and not minus 1. And therefore the value of x6 equals -4. To simplify our calculation, we multiply each term from the equation x6 equals x4 minus 1 by x to the power of 2n and obtain x to the power of 6 plus 2n equals x to the power of 4 plus 2n minus x power 2n. This leads us to the relationship as 6 plus 2n equals as 4 plus 2n minus as 2n, where n is a positive integer. By applying this relationship, we can easily find the value of as 6 plus 2n for n equals 1, 2, and 3. In conclusion, we determine that as 12 equals -4. And with this information, we successfully determine the solution to our problem. As mentioned earlier, we can also get help from the technology. Using GeoGebra, we are able to find all the complex roots as shown as Z1, Z2 until Z6. The animation shows the various values of Sn, and we can see again S12 equals -4. Thank you for joining me today. I hope you found this lesson informative and enjoyable. Until next time, take care and bye-bye.